Okay, here we've got what's called, questions with reciprocals. Okay, and this section involves basically a lot of word questions. And you have to essentially diligently work your way through these word questions. And the equations tend to be very simple at the end. So, we have a boat has a mast of 6 meters. So we have to know that a boat mast goes up and down. A wire runs from the top of the boat to the front, from the top of the mast to the front of the boat. So if we look at a side view of a boat here, I can have a wire here. And so I know that this is 6 meters. And it says let x be the angle of inclination of the wire. And so the angle of inclination of the wire is x. Oops, I forgot to figure out our questions are determine the length of the wire. So we want to know the length of the wire. Find length of wire. In terms of x. Remember, when something says in terms of x, then your equation is going to look like L is equal to some numbers times x, or divided by x, or plus, or sorry, divided by some numbers. But the variable in your equation is going to be x, okay? And so in terms of x means that L needs to be equal to x and some other stuff, okay? And so this is just an example here. Let's see here. Now if I go back and look though at my triangle, I can see that the mast is always at right angle here. I can see that the opposite side and the hypotenuse are being used here. So interesting. I know that the cosecant, yes, the cosecant of an angle, cosecant of an angle is equal to the opposite over the hypotenuse. And so it would be, I'm sorry, it's the hypotenuse over the opposite. So in this case, the cosecant of x is equal to L over 6. Remember, the cosecant is equal to the hypotenuse over the opposite, or the hypotenuse divided by the opposite. And so now if I solve for L, I can see that L is equal to, I'm going to multiply both sides by 6 here, so that'll cancel, is equal to 6 cosecant x. So there's my equation. Then it says, for part B, this is the answer to part A. For part B, make a graph of the function from x domain, from domain. So notice that x is going to be my input here, and it'll tell me the length of the string. So let's look at this equation real quick before we move on. So excuse me. So we understand what it is. Now x, it represents an angle, and this angle can only be, 0 basically, or 90 degrees. And what that does is that basically means the mast is always 6. What we can do is we can change the length of the boat so that if the boat is really long, then the wire has to be very long as well, and the angle is short. Let me give a couple of examples here. I've got a boat, the 6-meter mast, and there's my angle x. It's a short boat. What if I've got, a really long boat? And the 6-meter, I kind of messed up that drawing, but notice my wire gets a lot longer and my angle gets a lot shorter. Okay? And so these are the situations. Now I could vary this angle to all the way up. If I have an infinitely short boat, then the angle actually could be 90 degrees in theory. Or if I have an infinitely long boat, excuse me again, if I have an infinitely long boat, this angle could reach 0. And so that's why the book asks to make a graph of the function from the domain x is an element of 0 to pi over 2. And remember that pi over 2 is 90 degrees. So I'm going to be making a graph of this function. And so my x value is angles, 0 and pi over 2. So we know that when this is an angle, when the angle is 90 degrees, or when going back up to the picture, when the angle is 90 degrees, then my boat is infinitely short, and the wire that connects the top of the mast to the front of the boat is 6 meters. And so 6. And then as we get higher, or as the angle increases here, or sorry, as the angle decreases, meaning what I meant to say, if the length of my boat increases, goes way out here, then the angle decreases to 0 almost, and we should see basically what it is an asymptote situation. Okay, and so this is the graph of the function from the first from this domain, from 0 to 2 pi, or from 0 to 90 degrees. Oops, I forgot to write my 6 there. So you'll want to have the 6. You'll want to have the labels on your graph. And you'll want to graph it for sure. This is actually the 6 cosecant x function. Okay? Because the cosecant x has an asymptote at 0. And it comes down, and at 90 degrees, it reaches, the lowest point it will reach is 1. The normal cosecant graph. The lowest point it will reach is 1. But because this cosecant graph is multiplied by 6 up here, it's basically an expansion. It's been expanded by 6, or stretched. And so therefore, what used to be at 1 is now at 6, and all these other dots would be larger as well. Let's look at another question here. It says, interpret the meaning of the graph as x approaches 0. I've already basically interpreted that. What that implies is that the length of the boat will become infinitely long, because if I've got an infinitely long boat, then my angle here becomes really, really small, or infinitely small. And then my length, actually, of my wire would become infinitely long, basically, as well. And so the idea, well, that's basically what it is. You can just write something about how the length of the boat becomes infinitely long and the angle becomes infinitely small, and therefore the wire must be infinitely long to reach from the top of the mast to the front of the boat. And so that's questions with reciprocals. They're basically, a lot of them are along the same lines. My advice would be to practice them, ask a few questions in class if you're having trouble with them. Okay.